Thank you for joining us. This lesson, like the others, will focus on a variety of topics, each focusing around a book. Each lesson has materials that your child will need, as well as directions for activities centered around the book of the week. These lessons are meant to be completed across several days, and if you have siblings, brothers or sisters, or other adults at home, they can help as well. Today's nonfiction text will help us with measuring and estimating length, as well as exploring the strength of a magnetic force. This same video will play every day this week, so don't worry if you miss an activity or a step. You can tune in the next day and pick up right where you left off, or give the experiment a try again. Our featured book this week is Magnets, Pulling Together, Pushing Apart by Natalie M. Rosinski. If you have the book in your home, read the book to your child while you ask questions about the pictures and words they see in the text. If you don't have the book at home, have your family scan that QR code on the right-hand side of the screen to access a read aloud of the text. The QR code will take you to a YouTube video of the read aloud. You will need to use your student's district login information to access the recording. You'll be prompted to enter their district email address, username, and password. Be sure that as you are listening to the read aloud, that you're in a nice quiet spot and that you can pause that video throughout to still point out some of those keywords or discuss pictures. And of course, discussing the questions we have provided. Here are some questions that you can discuss while reading or after you've read the text. The first question is referencing the table of contents. Can you tell me where in the book you could find information about how magnets work? Second question, why do you think magnets can work through a covering? What is the specific scientific word for a push or a pull that can make an object move? How do you think magnets can be used to help people do things? Can you find evidence in the captions to support your answer? And lastly, why do you think the author wrote this book? What is the author trying to explain? So be sure to keep those questions in mind as you either read or listen to the read aloud of our featured text, Magnets, Pulling Together, Pushing Apart. In this next activity related to the book, your child will have an opportunity to let their mathematician and scientist skills shine. You may want to take a quick moment and snap a picture of the materials that you will need. The materials for this activity are a magnet, paper clips, ruler, some paper, and a pencil or a pen. Ask your child to go back to page 8 of Magnets, Pulling Together, Pushing Apart, where the text described how when magnets touch or get close to a metal, the metal objects become magnets. So let's take a moment to go back to page 8. In this activity, your child will investigate how magnets turn metal objects into more magnets and measure how long a magnetic chain can get before gravity affects and overcomes the magnetic force. So the first step in our experiment here today, have your child put all the paper clips in a nice pile so that none of the paper clips are linked or connected together. Ask your child to imagine what would happen if they held their magnet over the pile of paper clips. How many paper clips do they predict their magnet will be able to pick up? Like a good scientist, let's record our prediction on our paper. So record your prediction of how many paper clips do you think your magnet will pick up when held over the paper clips? Go ahead and record your prediction. Now, using the QR code on the right-hand side, watch the video, Junkyard Heavy Electric Magnet Machine Picking Up Scrap in Our Truck. This video shows a real-world example of the experiment we're about to conduct. So have your family scan that QR code to watch the video. After you've watched the video, have your child now take the magnet and hold it over the pile of paper clips, just like you saw the junkyard machine do in the video. Next step is to take that magnet and have them pick up and carry, without dragging, as many of the paper clips as they can to create a second pile. So hovering that magnet over the pile of paper clips, you want to carry as many as you can to create a second pile. Once you've created that second pile, count the number of paper clips in this new pile and record that data on your piece of paper. Let's count the number of paper clips in the second pile and record that information. Now we're going to be applying some of our math skills to our experiment. What is the difference in the number of actual paper clips in your second pile compared to the prediction you made? I said difference. So which of our math operations will we need to use to determine the difference? That's right, subtraction. You're going to subtract your prediction from the actual paper clips in the second pile to determine the difference. Let's do that on our paper now. Let's find the difference. Now, I would like you to imagine that your paper clips are arranged end to end. Which unit of measurement would be best to measure the length of your paper clip chain? Would you use either inches, feet, yards, centimeters, or meters to determine the length of your paper clip? If you said inches and centimeters are most appropriate, you're right, because paper clips are relatively small in size, so inches and centimeters would be most appropriate to measure. So now take your paper clips and line them up end to end. So line them up end to end. After you've lined them up, I want you to estimate using inches and centimeters. How long do you predict your chain of paper clips is? Let's record that prediction in your notes. Once you've recorded your prediction, it's time now to actually measure the length of your paperclip chain. You're going to measure using customary units and metric units to determine the length. Once you've determined the length, let's record that in your notes. And then look and see how close was the actual length to your estimation. Were you close? Now, your child's going to estimate how far away the magnetic force of their magnet can be felt. Have them make an estimation of how far they predict this force can be felt using both inches and centimeters. So how far do you think you'll be able to feel that magnetic force? And let's go ahead again and record that on our paper. Now that you've recorded your prediction, let's bring our magnet closer and closer to the paper clips. But you should stop moving once you start to feel the pull of that magnet, or you can see the paper clips move. Stop there and get ready to measure. Go ahead and now measure the actual distance of that magnetic force. And then compare it to your prediction. Did you have a big difference from your estimate and the actual magnetic pole? Take this time now to explain what that magnetic field or force felt like to you, to your family members or a friend that's helping you with this lesson. What did that feel like? And now, if you and your child are looking for more magnetic experiments, try the activities in the back of the book. There are options there for you to make your own compass or to make a magnet with electricity. But in conclusion, for today's lesson, we use the nonfiction text Magnets, Pulling Together, Pushing Apart, to measure and estimate length, as well as explore the force of a magnetic field. Don't worry if you missed any steps. The same video will play every day this week. Thank you, and we hope you've had some fun while learning.